Let's throw away whatever we know about coordinates for the moment. A point, as most people will understand it, is simply a little dot in space. If I say, look at this point, nobody will know which point I'm talking about. Let's consider the analogy where the point I'm talking about is occupied by a bird. I'm standing in a field where there are many birds flying about, and I say, look at that bird. Which bird? There are two ways I can specify this precisely. The first and more intuitive way is that I could point at the bird, and that will tell you the direction. But I will also need to say how far the bird is away from me, especially because there might be another bird in the same direction that I'm pointing. If I can specify the direction and distance, you will know which bird I'm talking about. What better way to put direction and distance together than an arrow? This arrow tells us the direction and distance, and we call it a position vector with origin at my fingertip. We will write the position vector as OA, where A is the point that we're talking about. The second way is that I could say 0 meters to the right, 2 meters forward, and 4 meters above my fingertip. Then everyone will be able to know which bird I'm talking about. I could write this as a bunch of coordinates x, y, z equals to 0, 2, 4, where x is the axis pointing right, y is the axis pointing forward, and z is pointing upwards. All this while, I've been taking my fingertip as the origin, the point 0, 0, 0. Let's step back and look at what we've got from these two methods. The first one gives you an arrow, and the second a bunch of coordinates. Both ways tell me which point or bird I'm referring to. In other words, the position vector and the coordinates are different ways of representing the same point. So, you don't have to be surprised when we say the point r vector equals to 3, 2, 4, because the position vector is just a way to represent a point.